Fundamentals of thermodynamics. The necessity of thermodynamics. Thermodynamics historically emerged as an empirical science of the major ways of converting the internal energy of bodies to perform mechanical work. However, in the course of its development, thermodynamics penetrated all branches of physics, where it is possible to introduce the concept of temperature and allowed the theory to predict many phenomena long before the rigorous theory of these phenomena. Basic concepts and definitions. Thermodynamics, the science of energy conversion laws. In thermodynamics, the widely used concept of a thermodynamic system. Thermodynamic system is a collection of material objects, interacting, both with each other and with the environment. All bodies are outside the boundaries of the system called the environment. Since the same body, the same substance under different conditions can be in different states, example, the ice-water vapor, one substance at different temperatures are introduced, for convenience, the characteristics of the state of matter, the so-called state parameters. Thermodynamic processes. If the thermodynamic system changes at least one of the parameters included in any body's system, the system thermodynamic process occurs. The basic thermodynamic parameters of state P, M, T homogeneous body independent of one another and are mutually connected. The equation of state. For an ideal gas, equation of state can be written as, if you know the equation of state, to determine the status of the simplest systems is sufficient to know two of the three independent variables.
What do you know about the first law of the thermodynamics?
The first law of the thermodynamics as the law of the conservation of energy in mechanics, often making it possible to investigate the thermal processes in macroscopic systems, even in cases where we don't know the details of the microscopic picture of the phenomenon being studied. The first law is universal. It is applicable to any and all thermal processes in system. Like any law of conservation, it does not give detailed information about the process, but allows you to create a balanced equation if you know in advance which energy transformation occur in the system.
What do you know about the second law of thermodynamics?
The second law is the thermodynamic, the physical principle, the restriction imposed on the direction of the processes that can occur in the thermodynamic system. The second law of the thermodynamic, so-called perpetual motion mechanism of the second kind, showing that the efficiency is not free to unity. Since the the process of the refrigerator temperature cannot be equal to the absolute zero. It is impossible to build a closet along the basis from the point with the 0 point. The second law of thermodynamics is a postulate not argued in the framework of the classical thermodynamics. It was created on the basis of generalization of the experimental facts and has revised numerous experimental confirmations.
What do you know about thermodynamics of nature?
I don't know.
There's only a few unbreakable laws in the universe, and one says that disorder always increases. We see this play out everywhere. Unfortunately, some people think this law is a problem for evolution.
Some people have said that life is basically applied chemistry, and chemistry is essentially applied physics. So then in that case, is biology applied physics? Although, you might say that physics is applied math, so I don't know how far we want to go here.
Well, without biology, there wouldn't be physicists, but you have a point. Like anything else, life obeys the universe's laws. A physicist might say you and a bacterium are both ordered bunches of particles. You're just a fancier and more complex arrangement. But surely, saying you evolved from something like that breaks the second law. How could evolution add order and complexity to life? There's something you haven't been told about the second law. It only applies to closed systems, and Earth is not a closed system. If you took a pan of cookie dough, half frozen, half room temperature, and put it in a cold oven, eventually, thanks to entropy, you'd get a bunch of equally uncooked cookies, even though the total amount of energy has remained the same. But if we turn on the oven, if we add energy to the system, our disordered dough can transform into something deliciously ordered. The sun is like our oven. It's constantly showering Earth with more energy than we can use. That energy changes DNA. Plants use it to make more plants. Animals make more animals.